Hello everybody, this is Dr. Noor Shah. Today video is about other methods for numerical solution of ordinary differential equation, in which I'll be talking about calculated tricks and MATLAB implementation as well. So पहले हम बात करते हैं other methods की derivation की कि कैसे how does it work, और फिर इसके बाद इसके कैलकुलेटर ट्रिक्स भी हम कर सकते हैं और इसकी मैटलैब इम्प्लीमेंटेशन की बात करेंगे. So if you want to solve a differential equation of the form y dash is equal to f of x y with y x naught is equal to y naught, it's an initial value problem and that's the initial condition. We first discretize this differential equation. इसका मतलब होता है कि हमने उसकी एक स्पेसिफिक पॉइंट पे इसकी डेरिवेटिव और इस फंक्शन की वैल्यू को कंसीडर करनी है, which might be represented as yn dash, that means derivative of y at x equal to xn and y equal to yn, that is equal to f of x and yn for n equal to 0, 1, 2 up to specific number of points, जिसमें हम इस डिफरेंशियल इक्वेशन को एक इंटरवल के ऊपर सॉल्व कर रहे होते हैं with some value of h. Okay, we apply forward differences to write this derivative in the form yn plus 1 minus yn divided by h, where h is obviously the width, that is equal to f of x n yn, right, which could be simplified in this form yn plus 1, that is equal to yn plus h f of x n yn with n equal to 0, 1, 2, 3 and so on. This is known as a classical or simple Euler method for solution of ordinary differential equation. So if you take n equal to 0, that will give you y1, that's the first solution of y at point x equal to x1. When you put n equal to 1, it gives you y2, which is y1 plus hf of x1 y1, which will give you solution of the differential equation at x equal to x2 and so on, so on. Okay, so this is the classical Euler method. Okay, let's do an example for it. Let's suppose we have a simple IVP, that is y dash equals y minus x with initial condition is x equal to 0 when then y is 1 by 2. Let's do that by using Euler method by taking different values of h. H is 0.1 and then we have h equal to 0.05, and we need to approximate this value y of 1. Right, keeping in mind when we take h equal to 0.1, that means we will be finding y1, y2, y3 up to y10. y10 will be the approximation of y1, and if you take h equal to 0.05, in that case it will give you you need to find y1, y2 up to y20, and y20 will be giving the approximation to y of 1. Right, so if you are decreasing the value of h, the accuracy of y1 will be increasing. Okay, so in this case we have f of xy is y minus x, whereas x naught is 0, that's the starting value, and y naught is 1 by 2. If you take h equal to 0.1, so in that case x1 will be 0.1 because x naught is 0 and x1 is x naught plus h, x2 is 0.2, x3 is 0.3 and so on, unless we reach to x10, which is equal to 1, and we have to find corresponding y1, y2 up to y10. Right, the Euler method is what? That is yn plus 1 equals yn plus f of x and yn, and in this case the value of n will start from 0 and going up to 9, because we are interested the final value is y10, so n should be 9 when you get y10. Now we would find y1 first, that is y1 equals y naught plus h y naught minus x naught, because f of x naught y naught. If you see, y1 will be y naught plus f of the h is missing here, sorry, so that is h into f of x naught y naught. F of xy is y minus x, so we get h into y naught minus x naught. Now by plugging in the values, y naught is 0.5 or 1 by 2, h is 0.1, whereas again putting the value y naught is 0.5, whereas x naught is 0. That will give you the first value or approximation of the solution at x equal to 0.1, that is 0.55. Whereas similarly we can find y2 as well. So y2 will become y1 plus hy1 minus x1. Wherever you had y naught in this one, it will be replaced with y1 now. So it is 0.55 plus 0.1 into 0.55 minus 0.1, that gives you 0.595. Now you see, if you want to find y1 with h equal to 0.1, we need to find y10. So there are 10 times you will do these calculations. So it's time consuming. Now can you do this by calculator directly? So the answer is yes. There is a trick to do that, and I'm going to explain that. To find all these values for n equal to 0, obviously you have a x naught, whereas y naught will be 1. Where for n equal to 1 we are having x1 is 0.1, whereas corresponding y1 which was found earlier, that is 0.55, and then we have see that x2 y2 it is 0.595 and so on. Now how do we get these values? By using calculator, maybe in one step or something. Not in one step exactly, it means you will be finding every value in with one click or something like that. So let me explain that with calculator. Okay, and you see, obviously the mode should be in maths mode, which is already there, and I have just fixed the value to 4 dp. Okay, and now what do? We have the formula that yn is equal to yn minus 1 plus y f of x n minus 1 y n minus 1. In this case, obviously n will be starting from 1 then, because we'll be finding these things. It doesn't matter, we can take yn plus 1 is equal to yn plus h f of x n minus yn. Still h is missing here, so okay. Now what do we do? How do we do that? By using calculator. So simply press alpha and just type y for it. So y and then again shift alpha to get equal. ये ज़हन में रख लें कि आपने ये वाला इक्वल नहीं प्रेस करना, ये अपने इसको प्रेस करना जो कैल्क के साथ आता है, और वो आता है अल्फ़ा के साथ. Now y is equal to y. Again देखिए हमारे पास फार्मूला क्या है? y is equal to y. So this is previous value, this is a new value, updated value. So y is equal to y again, and then we have simply plus, then we'll be having h, that's the h, and in this case my h, let me represent h by what? By m. You can use a, b, c, d, whatever you want to use, because we don't have h symbol here. तो h अगर नहीं है तो आप कोई भी यूज़ कर सकते हैं. आप m को यूज़ करना चाहें, आप f को यूज़ करना चाहें, whatever. And then we have multiplied by a function f of xy, which was defined as y minus x. So you can simply define the function, which is y, and then we have minus, and then we have x. That is x, and then we simply close the bracket. So you see we have done that. Yn plus 1 is equal to yn plus h times yn minus xn. Now you would press calc. It will ask for y, initial value of y, that is 1 by 2, I presume. I just forgot what was that. Yeah, the initial value was 1 by 2, yeah. So if you take this is 1 by 2, it's not 1. Let me change this one as well to make it correction, whereas this is h here, so I might forget later on, so change this one. Okay, so now what do? If I go back to calculator, so it is asked for y, so y is my 0.5, so I'll just give 0.5, or maybe you can give it 1 by 2. Then you will press equal. It will ask for m, that is h. So h in this case is 0.1, so we simply take its 0.1, 0.1 is here. So just press equal. Now it will be asking about initial value of x. So the initial value of x was 0, so we simply give it 0, and then we press equal. That is the first value of y, which is 0.55. You see, that's exactly the same thing. For the next value, what would you do? Simple press equal. You don't need to do anything again. You press equal. Y is okay, because we will be using now 0.55, and then I'll press equal. Now h is fixed, that is 0.1. Yeah, I need to change the value of x, because the x is now changing from 0 to 0.1. So it will be replacing only the value of x every time. So that give you 119 by 200, which is 5950, the second value. Again press equal, simple value is same, then you press equal again. We have m, you press equal again. X, now x will be changed from 0.1 to 0.2, and then you press equal to get the next value, which is 0.6345. Okay, press it again, y is 0.6345, press it again, m is fixed, and then we have 2, so you could replace that with 0.3 now. Okay, so we get 0.3, and then we will be getting what, 0.66 80, but it is maybe have taken there. अब यहाँ पे मैंने इसको फिक्स किया हुआ है 4dp तक, तो ये उन्होंने राउंड ऑफ कर दिया 0.6680, and so on. So you can do that for all values, and you will do that in sequence. You cannot jump directly to 10 because the previous value is used for the next value. So y is same, you can go for m is 0.1 same. Now you'll take 0.4, and then you simply take this is equal, which give you 0.6947. You see that this one, right, and so on, so on. Okay. I hope it's clear to everybody. Now the next part is we were doing all these things for 0.05 as well. Okay, so we can do, what would you do? You don't need to change anything because example is exactly the same. The only difference you will be having here is h को change करना है आपने. तो इस केस में अगेन हम इक्वल को प्रेस कर देते हैं. अब y अगेन वही हम 0.5 लेंगे बिकॉज इनिशियल वैल्यू हमने दोबारा से स्टार्ट करना है. Then we go for m. M is now 0.05, you see, because h is 0.05, and the x will be taken 0 as well, starting from 0, and then you press equal. We have 21 by 40, which is not here obviously because we are displaying for x equal to 2 only, n equal to 2, that is for x equal to 0.1. This is the value for x equal to, I don't presume we don't see it. Yeah. So we don't see this. It was okay, something here. Okay. So you see that if you press next one, so y is this one, m is fixed now. Now it will take x to be now 0.05, keeping in mind because you see h is 0.05, x naught is 0, so you'll be adding 0.05 to it to get x1. When you press this, you get the next value, which is 0.54, yeah, 74 or something. It's again it is rounded off, so and so on. So again you press equal, and then you give the value now 0.1 to x, so 0.1 is okay now. Then you press this value, that is again we don't need this value, so let me go back. So it's 0.5712. We are displaying only even ones, so you can do either one because n equal to 20 है तो ये बहुत लंबा बन जाएगा, इसलिए हम सिर्फ इसमें even को display कर रहे हैं. Okay, press it again. So we had now 1.15, 0.15, and that will give you the next value, which is 0.5922. And so on, so on. You can do this for all the values to get the last one, and you can compare this value with exact as well because solution of this equation can be found easily, the exact solution, so it's okay for everybody. You can compare the values as well. Okay, now let's go to the next method. So it is done already. You see that when h is equal to 0.05, we have this formula now, and then by applying using calculator, you can find all these values which are yn. So this yn are the approximate values, whereas exact solution is also given. You can find the error in the last value and the exact value, that's y20, and the difference between y1. So this one minus this one, see, this one minus this one, that's the error, absolute error, by using Euler method. But that is improved when you decrease h, but obviously you have to do many steps. Okay, next we talk about the variations of Euler method. The first variation of Euler method is usually known as modified Euler method, okay, which is used for solution of the same type of differential equation, that is IVP. Will be given initial condition as well. So we have y dash plus f of xy, that is yx naught equal to y naught with initial condition. Okay, this variation is given by, instead of going for yn plus 1, that was yn plus h f of x n plus h by 2, yn plus h by yn was replaced. Now you see we are not taking xn anymore, हम ले रहे हैं xn plus h by 2 और yn की जगह हम ले रहे हैं yn plus h by 2 f of x and yn. इसका मतलब ये है कि हम प्रीवियस वैल्यू पे उसको फाइंड नहीं करना चाहते, हम थोड़ी सी परटर्बेशन x की वैल्यू में भी कर रहे हैं और साथ में y की वैल्यू में भी वही परटर्बेशन कर रहे हैं. Okay, we are going to use this formula to find all those values, so we can do that. The next variation is what that is known as improved Euler method, in which we do what? The problem is same. So we first use Euler method. That's the simple Euler method, which is using the previous values xn and yn, right? And then we find another value, which is the improved value of yn, by using again Euler method. लेकिन यहाँ पर हम क्या कर रहे हैं कि xn के बजाय हम xn plus 1 को यूज़ कर रहे हैं और yn की जगह हम yn plus 1 स्टेरिक, जो कि यहाँ से हमने फाइंड की थी, और फिर इन दोनों का एवरेज लेते हैं. That will be the next value for the solution. So it's yn plus 1 steric plus yn plus 1 double steric, and if we put these values back to get this formula, you see that yn plus 1 steric is you simply add them, yn plus yn divided by 2 give you yn. This h and h is h by 2, which is f of x and yn coming from this one, whereas f of xn plus 1 yn plus 1 steric coming from there. Okay, now we can further put this value from here again. So yn plus 1 steric could be replaced with yn plus h f of x and yn. This is basically because of this one. We may multiply this one h. Just to write this formulation in a simple way, we can multiply this h inside to get hf of x and yn plus hf of x n plus h, because xn plus 1 means the next value, which will be xn plus h, whereas this is yn plus h f of x and yn, and this could be simplified as 1 over 2 k1 plus k2. We called this one as k1 and we can label this one as k2 or whatever you call it. Okay, where k1 and k2 has the specific values. K1 will be h times f of x and yn, and k2 is h f of xn plus hyn plus k1, where k1 will be found updated from here. Okay, so let's do same example we've done a bit earlier with Euler method. इसको हम दोबारा कर रहे हैं अब modified के साथ और improved के साथ, and let's see कि उनके results जो हैं वो कितने improve हुए हैं. So let me have same example. Okay, we are solving the differential equation y dash equal to y minus x. Y of 0 is 1 by 2, and we need to apply modified and improve Euler methods to get results for 0.1 and 0.05. I may discuss only 0.1. You will simply do everything a similar way as I have done in Euler method to obtain this approximation of y1. So in this case again, f of x y is same. You don't need to be worried. Whatever you got on the right side of the differential equation, you need to convert differential equation in this form first. आपने पहले इसको लिखना है y डैश इज इक्वल टू एफ ऑफ एक्स वाई. ओके, इसके बाद फिर आप ये आगे सब कर सकते हैं. जितने भी न्यूमेरिकल मेथड्स हम यूज़ करते हैं उनके लिए पहले आप यही कर रहे होते हैं कि y डैश को लिख रहे होते हैं in the form f y dash equal to f of x y. Now x naught is 0, y naught is 1 by 2, okay, and so on. If h is equal to 0.1, this will give you these values as x1 is 0.1, x2 is 0.2, up to x10, which is 1, and then we would find y1, y2 up to y10 by using both method, modified and improved Euler method. Now we first talk about modified method. That is, you see, formula is given as yn equals, that's again it's h time, yn plus h f of x n plus h by 2, yn plus h by 2 f of x and yn. Okay, again it's h is missing here. Okay, so if you want to find y1 first, so you'll take y naught here plus h, and function is again y minus x. I'll be replacing complete y with this quantity, so it's y minus x. So I'm taking y naught plus h by 2, y naught minus x naught, because f of x and yn is y minus x, and then minus this quantity. I hope it's clear to everybody. थोड़ा सा ये मैंने इसको डायरेक्ट लिखा हुआ है, लेकिन आप इसको देख सकते हैं. इसी ये यहाँ से लेकर यहाँ तक ये पूरा क्या है, ये y है, ओके, दिस इज़ y, वेयर एज ये जो हमारे पास पूरा आ रहा है ये x की तरह बिहेव करेगा, बिकॉज यू सी दैट हमें फंक्शन की वैल्यू कहाँ पे चाहिए, यहाँ पे, स्टिल मिसिंग द h, और फिर दोबारा जो नेक्स्ट है ये आपके पास x है एंड दिस इज़ और y, सो हमने इसको रिप्लेस करना है y के साथ, इट y माइनस x, और यहाँ पे इधर भी हमारे पास ये f ऑफ x y है, x नॉट y नॉट है, तो यहाँ पे जो आप देख सकते हैं कि y नॉट माइनस x नॉट कहाँ से आ रहा है, वी आर पुटिंग दिस वैल्यूज़ इन द फंक्शन f y माइनस x, यहाँ पे इसमें हम पुटिंग कर रहे हैं विद x इक्वल टू x नॉट एंड y इक्वल टू y नॉट। सो इसे आप कंफ्यूज ना हो कि हम ये सब क्या कर रहे हैं, राइट। सो इसी दैट पुटिंग दिस वैल्यूज़, if you put x y naught to be 0.5, h to be 0.1, for the second problem 0.05, we'll be replacing this with 0.05, and then we have y naught, so it's 0.5, h is 0.05, 01 divided by 2, that gives you 0.05, and then y naught is 0.5, x naught is 0, minus x naught is 0, whereas h is 0.1 divided by 2, so 0.05, and that will give you 0.5475. Right, so I'll be explaining how do we do that by using calculator, so it's a simple concept. The same thing can be done for y2 as well. It's y1 plus h, y1 plus h by 2, y1 minus x1 minus x1 plus h by 2. Now putting all these values back to get 0.5895, and you may compare these values how close they are to the actual value, and that can be done in this table. Okay. The same thing for improved as well. y1 is equal to y naught plus 1 by 2 k1 plus k2. I'm explaining both at the same time in calculator, so don't worry. So y1, that is equal to y naught plus half k1 plus k2, where k1 is this one. Now we would find first k1, which is h f of x naught y naught, that is h times f of xy is y minus x, so we have h times y naught minus x naught, putting the values to get 0.05. Then we would find k2, where k2 is h f of x naught plus h y naught plus k1. So replacing these values, so we have y naught plus k1 minus x naught plus h. Again, it's y minus x function to give you 0.045. Now putting this and this value in y1 and putting the value of y naught as well, so we get 0.5 for y naught, it's 1 by 2, k1 is 0.05, and so on. When you simplify this, you will get 0.5475. It's almost similar to the modified one, but it is improved when you increase the number of significant figures. Okay, the same thing for y2. So y2 is equal to y1 plus half k1 plus k2, where k1 is now h f of x1 y1 instead of x naught y naught. Now putting this value is x y1 minus x1 for f of xy. This is 0.0448, whereas k2 will be h f of x1 plus h y1 plus k1, and then putting the value in the function to get y minus x, so that is 0.0392. Now putting these values in this formula now to get y1, which is 0.5475 from here, that's the y1, and plus 0.5 into this is k1 obtained from here, k2 is obtained from here, that give you 0.5894. Okay, now these values can be compared with each other, like for sorry, again it's a mistake, this is 1 by 2, 1 by 2, 1 by 2, it's not 0, 1 1 1. Okay, now you see you can simply find the values of this exact value. This is the Euler method, this is the modified Euler, and this is the improved Euler. But you see that these values they basically coincide up to 4 decimal places, but obviously improved will be showing different results when we increase the number of significant figures. Let me do that. I'm increasing now significant figures, so I may get different results. I have done that with 4 significant figures. Let me increase the number of significant figures as well, so we see what happens. So shift, and then we go to mode, and then you see 6 is giving you fixed the value, so just press 6 and give it 9, so it will be now up to 9 decimal places. Okay, I may go to simply okay, so that is okay. So let's do first the modified one and see what's going on here. So for modified, we will do what? I'm going for y. Sorry, I'm going alpha, and then I'm going for y, and that is equal to again y. Okay, that is y equals y, and then we have plus, then we have h by 2. Let me go back to the formula so that I could do everything correctly. It was here somewhere. Again, let me write h here as well, so to get something right. Okay, so I'm going to use this formula. Okay, and you should keep that in mind. So how will we do that? So y is equal to y plus h. Okay, so I'll just call this m again, and then bracket is what? You see, I'll doing this one. So all together I'll be having again y naught, so which means y again, right? Y is this one plus h by 2. So I'll simple give that something m, and then we have divided by 2 into, again I'll be having y minus x. Okay, so I have done this part. Now y naught, this is y plus h by 2, which is m by 2 into y minus x, and then we have minus, and the next part is what? That will be x naught plus h by 2. So I'll just take a bracket here, I'll write x, and then I have plus, and then we have m by 2. So it is m from here, you go down, and then you take m by 2 and go up, and then close the bracket, and then again the next bracket. Now if you press this calc, it will ask about y. The initial value of y is 0.5. Okay, then it will ask about m, which is 0.1. Okay, and then it asks about x, which is 0 initially. It will give you the value of 219. It is 0.5475. Let me go to that table now. It's 5475, and the exact value is what? 0.5474. Okay, so we are having very close value now, 0.57. It's very better than what? The Euler one. The next step, you simply press equal. It's okay, don't need to change, and you have to put the value now. X is 0.1. अगर आपने इसको 0.05 के लिए करना है तो आपने सिर्फ h को चेंज करना है, m की जगह आपने 0.05 वैल्यू देनी है, और फिर यहाँ पे x की भी वैल्यू अकॉर्डिंगली चेंज हो जाएगी. पहले आप 0 देंगे, फिर 0.05 देंगे, फिर इसके बाद आपने देना है इसको 0.1 एंड सो ऑन. Just press equal, we get 0.58948. So it's 0.58948, which is rounded off to 0.95, and you see that it's 0.59299. So it's obviously improved from here because it's 0.59 from Euler. Again, you can go for the next value. M is 0.1. Okay, now you replace simply x with 0.2. Okay, and then you press equal to get the next improved value, 0.6254 or 53. So obviously you see that 383. So it is, again, it's very close to this one. You can find the error as well, and so on. So you can find all these values by simply pressing the equal button and then giving only the value of x to get these values, and that can be done in a flash. Okay, now what about the improved Euler? How do we do that? By using calculator. So let me do that for you as well. Let me clear this everything. Now what do we do in this case? We first find k1 and then we find k2. So for k1, let me call that a, where a will be my k1, keeping in mind, and that is h. So shift with m multiplied by y minus x. It's simply y naught minus x naught. The function is y minus x. I will write it's y, and then I'll take minus x. Okay, and then we go for the colon just to separate the value. We will be defining now b, whatever you call it, it's up to you. So b is k2. Okay, so b will be what? Again it is h, so you will take m here multiplied with y naught plus k1 now. So simple take again y plus a, because k1 is a, so you'll take y plus a minus x plus h. H is what? H is m, so we'll be taking x plus m, and then we close the bracket, this one, and then another bracket as well, and then we will be defining the final this equation, which is y1 equals, so we go for y equals again y plus, we have 0.5 multiplied by a plus b, k1 plus k2, so that is a, and then we have plus b. Then we close the bracket, and then you simply press the calc button before you move to the first value. See, this is we have pressed this calc button. Again it asks for m, which is obviously 0.1, don't need to change. It will ask for y, so y is initially 0.25, you don't need to change the value, and x initially is 0, so you'll get 1 by 20, which is 0.05. That's the value of k1. This is the value of k2 if you want to display, and then we have the same value what we had from for modified 0.5475. they are same. Now again you press equal, ask for this one, and then we have x will be 0.1, and then you press equal because it is finding a and b as well. Sometimes we are interested in writing them, and then we have 0.5894 or something, which is, yeah, to 4dp they are similar, but afterwards they are different. And obviously improved Euler is giving you improved value, so it's 0.2 now. That will give you equal, which is 0.625, and then we have 383, so on. So you can do the rest as well, just replacing the value of x and pressing the equal button to get all these values. It's 0.6545 and so on. Right, I hope it's clear to everybody now. Okay, so now let me discuss the MATLAB implementation of these methods as well. It's a very simple one. अगर आपको ये आइडिया हो गया तो इसमें मेरे ख्याल में इसका कोई इशू नहीं होगा आपको. तो यहाँ पे हम कह रहे हैं कि भाई मुझे y भी चाहिए सोल्यूशन और एरर भी चाहिए अगर आप एरर फाइंड करना चाहते हैं तो. So we will be giving values of x and f, okay, and then we can simply find h, that is x2 minus x1, okay, and then y1 the initial value which we give 0.5 in the previous case, and then it will do what? It will simply find k first. You can combine them as well, लेकिन इसको हम आगे जनरलाइज कर रहे हैं तो इसको हम अलग अलग ले रहे हैं. So it is k, which is the f of x n y n, see that, and we have yj plus 1, that is equal to yj. This is y naught plus h times k, right? It's दो तरीक़ों से हम करते हैं. बाज़ औक़ात h हम यहाँ पे मल्टीप्लाई करते हैं तो यहाँ पर मल्टीप्लाई करने की ज़रूरत नहीं होती. बाज़ औक़ात आप उसको यहाँ पे मल्टीप्लाई करते हैं तो वहाँ पे करने की ज़रूरत नहीं होती. And that will be doing for all values of j, जो भी हम करना चाह रहे हैं तो. And then the exact value is this one, if you consider that same equation, and this is the error, and then we have a plotting something. Okay, obviously जब आप डिफरेंशियल इक्वेशन को चेंज करेंगे तो आपने ये वैल्यू भी चेंज करनी है, या आप इसको बाहर से भी दे सकते हैं, आपकी मर्ज़ी है. अच्छा, अब अगर हम इसको रन करना चाहें तो आपको पहले क्या चाहिए? आपको पहले f डिफाइन करना है. तो f equal to And then we do for this one, it will be phi xy now, because we have to give a two variable function, and that was y minus x. Okay, so we have this function now, and then simply put this, copy this one here, Control C, and we have Control V. We can give the value of x, that is what it is. Maybe we define it first. Yeah, you can define this. X is equal to starting from 0 with an increment of 0.1 and going up to 1, because we want to find that in this range, so that is okay now. And then we go for the value. So x is defined, y naught is 0.5. Okay, and then you just put the value, input the value. It's obviously doing it, so you say it's 0.603, and that's the graph as well, if you want to plot them, the actual value and the approximate value. Okay, these are basically the actual. You can change the view as well, it's up to you. But I can feel I'm getting wrong value. I don't know if I think they are okay. These are the errors. Am I using same equation? I'm not sure exactly. We don't care about the exact solution at the moment, because we don't know हम कौन सा equation ले रहे हैं. We may go back and I check if I'm displaying the exact solution somewhere. You can solve this differential equation for exact solution. Okay, it's not worries. But I'm getting the same values for the values for Euler. See, it's with 0.05, and this is what? This is for 0.70. Am I get the same thing? 0.70. Yeah, 0.7031. You see that I get the last value same. So numerical is okay, but the error is too big, right? It is because of what? Because we might have used this as a wrong solution. So you need to introduce this one correctly. Okay. So that's for Euler method. In modified Euler, we only change this quantity here. We introduce k1, we introduce k2 as well, or maybe you can call it k, okay, which is f of x plus h by 2, and then we have yj plus h by 2 k1. See this one. So we just put in here, and you can run that. The rest is straightforward. And in case of improved Euler, it's almost the same setup. We take only k1 here, we take k2 here, and then we have yj plus 1 is this one, right? You can get rid of this h from here, you can use h here, whatever we got from here. यहाँ पे h लगा लें, यहाँ पे h लगा लें, और इधर पे ना लगाएं, यहाँ पे सिर्फ 1/2 लगा लें. It's up to you. Okay, so I think it's straightforward. दोनों जो कोड्स हैं वो तीनों ऑलमोस्ट सेम है. सिर्फ यहाँ पर एक पॉइंट है, उसमें सिर्फ हम ये फाइंड कर रहे थे आइलर में, ठीक है. फिर मॉडिफाइड में हम थोड़ा सा चेंज कर दिया इसको, यहाँ पर एक्स जे प्लस एच बाई 2 एंड वाई जे प्लस के बाई 2 किया था. अब यहाँ पर k1 और k2 को फाइंड करके फिर हमने वाई जे प्लस 1 इस तरीके से फाइंड करना है. एंड आई थिंक द रिमेनिंग आर ओके. सो आई मे ask you if you have any query, any question, you can just drop a message or drop a comment. I'll get back to you. Thank you very much, and see you in another video. Thank you and wish you good luck.